a slightly different variation of this, and it's still binomial probability, most or least. Um, and we're going to talk about the way it's worded and what that means. So if a fair coin is cost 6 times, what's the probability rounded to the nearest thousands of getting at most 2 heads? So you're going to toss it 6 times. You're going to get at most 2 heads. So when you think about it, the probability of a head is equal to 1/2. Probability of not a head, okay, so that would be a tail, is equal to 1/2. Remember, that has to add up to 1 because either you have a head or you don't have a head. Now, when you think about what this question is asking, is this is the probability that if you toss it, actually, we know that we're going to toss it 6 times. So toss 6 times. And the question is, what's the probability of getting at most 2 heads? Well, think about what that means. At most 2 heads. Isn't that the same thing as doing the probability of 0 heads plus the probability 1 head plus the probability of 2 heads? So we got to find each one of these to figure out what's happening. So we're going to have to do a little bit more work on this because we have to figure out each one of these things to kind of go on and do our thing. So let's do the first one. The probability of getting 0 heads. Six tosses, we're not going to get any of them. It's 1/2 is the probability of getting a head to the 0 times 1/2 probability of getting a head to the 6 plus. Now let's do 1 head. So that's 6, choose 1. Probability of getting 1 head is 1/2 to the 1st. But now we're going to have all the rest are going to be tails. So that's going to be to the 5th because remember you're tossing it 6 times. Finally, the last one is 6, choose 2. But now we get 2 heads and 4 tails. And then we're just going to do that in our calculator, and I'll let you do that in your calculator. You've seen me do it a number of times. You can just string those together and add those up using that Desmos calculator. Let me show you one more example. Let's see. Okay, let's try this one. Okay. So let's talk about this one. So a fair die, and notice that when they're talking about a dice on this, they're talking about a 6-sided dice, okay? So on this one, we have a 6-sided dice. Okay, the numbers 1, 2, 3, 4, 5, 6 are on this dice. And we're going to roll it 5 times. And the question is, what's the probability of at least 4 6s? Okay, so at least 4 6s. That means we could get 4 6s. We could get 5 6s. And that's the most we can get, right? We can either get 4 or 5 6s because we're going to roll it 5 times. Okay, so we can figure these out together. We can do one at a time. So let's go back and think about getting a 6. So the probability of getting a 6 is 1 out of 6. The probability of not getting a 6 is 5 out of 6, right? I mean, because either you're going to get a 6 or you're not going to get a 6. So when we go through this and we start to calculate this, and I'll scroll out so you can see it. 4 6s. So for this one, we're going to roll it 5 times. We're going to get 4 6s. And that's 1/6 to the 4th. And that's 5 6 to the 1st. Because that one time we don't get a 6 if we get 4 6s. Plus, now we still roll it 5 times, only this time we're going to get 5 6s. So we're going to get 1/6 to the 5th, but now we don't have any of the other one. So we don't get any of the other numbers. And that's going to be to the 0 power. And when we do this, we're going to come up with our, we should come up with our probability. Let me show you what I mean. If I go over to here and I do function, I do 5, 4, and I do 1/6 to the 4th power times 5 6 to the 1st power plus 5, choose 5, and then I do 1/6 to the 5th power times 5 6 to the 0 power. And what I get is I get 0.0033343621,399. Now you don't need all those decimal places because all this asks rounded to the nearest thousandths, so that's 3 decimal places. So if I just put 0.003, I should get the right answer, and it'll go through and show you how to do that. If you have questions, let me know. That should end all the videos. You should have enough information to do all the problems.